information on the new relationship between Doctor's Choice Evexia and Diagnostic Solutions Laboratory. Tonight we're going to be speaking about a DNA-based stool analysis called the GI Map. And as I said, my name is Tony Hoffman. I'm the CEO and President of Diagnostic Solutions Laboratory. I have been in the integrative functional medicine laboratory business for about 24 years, and we'll run through a little bit of my history as we move on. And also wanted to bring up that Dr. David Brady is our Chief Medical Officer. So as an overview, as I said, we're pleased to bring you the first integrated functional medicine stool profile that includes an FDA-approved panel for not only bacterial but parasitic and viral pathogens. And on that same platform, we've built out a number of other markers that we'll go through this evening. They include other normal flora, additional parasites, fungi, and of course, a host of other markers for inflammation, immune function, pancreatic function, etc. So as I mentioned, this is an FDA-approved technology platform used for all of our testing, and it's fully validated for the organisms we test and has a very rapid turnaround time. Our current turnaround time for the full GI map assay is about 4 days right now, and that's right within our 3 to 5 day window. So as we get going, years ago, over 100 years ago, Dr. Michnikov coined the phrase, "Death begins in the colon." And we all know that to be true. And over 100 years later, with the advent of DNA and PCR technologies, we're starting to see that we can look deep into the microbiome on the genomes of the organisms and see that not only does death begin in the colon, but certainly health and life and vitality, along with those diseases that Dr. Michnikov mentioned so long ago. We're able to see that now and be able to look into what might be the root causes for some of these shifts in the microbiota that do contribute to both health and disease. About 2005, there was a patent on Taq polymerase that hindered a lot of the research that was going on using DNA and PCR technology. Once that patent on Taq polymerase came ended, you're starting to see a very, very large increase in research studies and sequencing of everything in the microbiome, including genes on the genome of organisms that also contribute to disease and pathology. So there is a molecular revolution, and right now it's on a really logarithmic growth pattern. If you start to look into research articles around the world, you see that, again, in the last 12 or so years, a very logarithmic increase in research studies, both on microbes and our understanding of microbes, but also how those microbes might affect our health. So I want to talk just a few minutes about evolution of stool analysis in integrative and functional medicine. And this kind of goes back to, where I landed years ago. The first real foray into a stool analysis was Dr. Jonathan Wright's lab, Meridian Valley, in the 70s. In the mid-80s, what's now Genova Diagnostics, back then, some people might remember those Great Smokies Diagnostic Laboratory, came about. And they had a slightly increased version of the old CSDA that Jonathan Wright had started, and they named it the CDSA. Well, I went to work for Genova in 1993 and left there in 1999 and started Advanced Access Lab and private label stool testing to both doctors' data, Metametrics Clinical Lab, and also Great Plains Laboratory. Late 2001, that lab was sold to Doctors' Data, and after a period, I ended up at Metametrics Lab. And at Metametrics, we did the first foray into a DNA-based assay, and that assay was a pretty good first step towards, utilizing DNA methodology to analyze all of the microbes within the stool sample. It had some issues, certainly, but it certainly was the first good step. Of course, roundabout, Metametrics, I think it was 2012, Metametrics was sold off to Genova, and that assay was pretty much dismantled. They still have the GIFX. It does have a DNA-based portion on it. They're measuring a number of commensal organisms, but the majority of that assay fell back to culture and microscopy techniques. And so certainly there was not a true DNA-based test out on the market. So after leaving Metametrics when Genova did the buyout, I did start another lab, working mostly with gastroenterologists. And after a couple of years of that, got together with the current ownership of Diagnostic Solutions and said we really need to utilize some of the new technologies that are available to really make a true, easy to run, high throughput, fast turnaround time assay using some newer technology for the integrated functional medicine market, and that is Diagnostic Solutions Laboratory. So we've been open for right at 2 years now. So now let's check out some of the stool samples and see what these reports look like. So this is page 1 of the GI map. As you look, you'll see that there is a whole section of overt pathogens. So this pathogen section, the chronically ill patients, we do see them. They do have an effect on chronic patients. In mainstream medicine, they would be looking for patients with diarrhea and running a panel like this, and to get the diagnosis of shigellosis, salmonellosis, C. difficile associated diarrheal disease, etc. But certainly, they're very useful in uncovering chronic, low-level, persistent infections that are contributing to other diseases and may not be causing a high inflammation, and certainly may not be causing diarrheal disease. It can be very difficult to identify at all. The next section right below that, you see there's H. pylori. There are many methods for measuring H. pylori. Some labs still do H. pylori antigens from the blood. We know that technology is not really good, but certainly there's an H. pylori stool antigen that many labs might run, and that's a pretty good technology. It picks up most of the H. pylori. However, the sensitivity and specificity is not quite as high as doing a DNA-based assay. And if you notice, as we're starting to look at this report, just to mention, you see the H. pylori as 1.8 E3. E is for exponential numbers, so that is 1.8 times 10 to the third, or 1,800 cells per gram. We'll flag things high when they get above the reference ranges you see on the right side, and we'll call organisms when they get above 100 cells per gram. 100 cells per gram basically lets us know that it's getting into an overgrowth state. And most of these organisms are present in very trace amounts. And people ask the question all the time, are you just picking up trace amounts of an organism? And no, we have, cutoff values and positive call-up values that are equivalent to when an organism gets into an overgrowth. We don't want to know if there's 20 cells per gram for most of these organisms, because they may be at that level all the time as a true resident of your microbiota and causing or maybe posing no issues. Underneath the H. pylori, you see two virulence factors. The great thing about a DNA-based assay is we can actually measure for these genes on the genome of the H. pylori organism. So a virulence factor, in this case we have two that we're measuring, CAG-A and VAC-A, both of which increase the pathogenicity of H. pylori, but in different ways. They're both a type of toxin, and the VAC-A, the second one, is a toxin that causes gastroenteritis. And the first one, CAG-A, is a toxin that actually damages surrounding cells. So it can obviously be included in if it were in the stomach, may also be contributing to ulcers. As we move to page 2, at the top of the page, we see a number of normal bacteria flora, commensal and beneficial. We've chosen these 5 particular flora because in the literature it is suggested that these have a very fairly common reference range for all humans. There are a lot of flora in the GI tract, both commensal and beneficial, and a lot of the other organisms may be in varying amounts, and so it becomes hard to determine a reference range that has value, because there are numerous patterns that they're discerning from, like sequencing type technology, that might suggest that some people have a pattern of lower amounts of Rhamnococcus, but that might be normal for them. So we wanted to choose organisms that we could actually measure that have a normal or a realistic reference range across all people, and be able to tell when somebody's actually high or actually low in a normal flora organism. We think that's very important. The next group of bacteria you see are opportunistic bacteria. And we call them opportunistic because, again, they can be present in small amounts and may not pose much influence towards symptoms or influence in certain diseases until they get to a truly overgrowth state. And that's true of all bacteria, really. If you think about it, they're almost all opportunistic because so many of them are present in small amounts on a regular basis. So it's the increase or the overgrowth or dysbiosis that really causes a microbe to have an impact on our health. And so you'll see that there are autoimmune triggers, and we'll talk a little bit more about those a little bit later. There are additional dysbiotic or overgrowth bacteria. And again, we've chosen certain organisms to measure mostly based on literature and whether or not we can prove through literature and a lot of research that they have a measurable effect, and we know that they contribute to either dysbiosis symptoms or contribute towards the disease. And so we don't report a lot of erroneous or organisms that are just maybe present in the microbiota. We want to measure those things that we have, sound science behind. Things like Morganella, you tend not to see it in adults except for under certain circumstances. More in kids, and it can actually be a cause of diarrhea in kids. But we'll talk about a little bit more the correlation between Morganella and SIBO and H. pylori. Those are some things that we've noticed. But things like Pseudomonas, in this case we see positive high values for Pseudomonas species and Pseudomonas aeruginosa. Again, just to point out, Pseudomonas species you'll see at 1.3 E for 1.3 times 10 to the 4th, which would be 13,000 cells per gram. That's a high level. Pseudomonas is a genus that does have the possibility of producing a mild toxin, so it certainly can cause symptoms. The symptoms might be mild. It's not an overt pathogen, but in an overgrowth state, it certainly could be causing some inflammation and symptoms. And below the opportunistic bacteria section, you'll see parasites. And these are additional parasites beyond the pathogenic parasites that you've seen on page 1, the overt pathogens that cause a disease. Certainly familiar, Blastocystis hominis, Dantimiper fragilis, and Endolimax nana, and so on. Additionally, you'll see something like Cyclospora. That is an organism that's hard to measure under standard microscopy, but certainly is an opportunistic organism, and in an overgrowth state, it can actually cause quite a bit of symptoms in people, and in high enough amounts, third world countries, tends to be one of the more minor causes of diarrheal disease, so certainly it's an opportunistic pathogen. And then moving on, we see a section with fungi and yeast, and of course Candida albicans, and you do notice that some organisms are measured quantitatively and some are in a positive or negative. Part of the methodology and the ability to do quantitative live samples that are standardized, so we know how much is there, and build a standard curve and measure your patient against the standard curve to plot the actual, or to calculate the actual amount. So some of these protozoa you just cannot buy commercially that come from a standardized vendor to be able to do that. We can get Candida albicans, so you'll see that there's a reference rate for that. And in this case, you see it's less than DL, so again, less than 100 cells per gram. And then you see there's a low geotrichum. Low in this case suggests that it's somewhere over 1,000 cells per gram, but not in a moderate or high amount, and high would be well over 100,000 cells per gram. And then we move on to page 3, and you'll see some familiar analytes here, like pancreatic elastase 1, steatocrit, which is a measure of total fat, secretory IgA, and anti-gliadin antibody, IgA, and then calprotectin to check for inflammation. And you may be familiar with beta-glucuronidase, and of course fecal occult blood. So I do want to go a little bit into some of the markers that you may or may not be as familiar with in a few minutes. So we talked about the overt pathogens, and of course a lot of the other organisms contribute to dysbiosis, and then they may also be contributing to permeability or hyperpermeability. And here's a list of diseases and symptoms that may be associated with things other than overt pathogens that we may want to run a stool test for. So as we talked about the advent of DNA, we've always had an understanding that the microbes themselves have genes and different proteins that they produce from those genes. They produce these particular metabolites. And now there's becoming a much better understanding of how these metabolites might interact with the mucosa and with us as the host. So we're starting to see a revolution now, not only in being able to measure organisms, but I would predict in the next 5 years that we'll start to have other assays measuring the genes for the production of metabolites. And if you didn't know, there's actually a gene for butyryl-CoA and acetyl-CoA, which is necessary to be present on the genome of the organisms that produce short-chain fatty acids. So you can actually have a good balance of flora, and if there is not enough of that particular gene present, the organisms, although they're present, would not be able to produce N-butyrate, and acetate. And these are newer findings, and I think over the next 5 or 10 years, we'll start to look at measuring a lot of these genes as a way to determine the microbiota's ability to produce various metabolites that are both harmful and maybe beneficial to us, the host. So not included on the sample report you just seen is zonulin. It is an add-on, and we'll talk about pricing and other options besides the GI map in just a few minutes. Zonulin is an add-on, and as everybody might know, zonulin is in charge of or determines how much permeability there is for absorption of the micronutrients that we need, but also in very elevated amounts causes hyperpermeability by opening the TJ cells, the tight juncture cells that are in between our cells of the mucosa. And this slide points out Dr. Fasano's group recently in 2002 published a study that showed bacteria such as E. coli, normal flora bacteria, and of course salmonella can stimulate zonulin production. And so we find that interesting that E. coli can actually stimulate the production of zonulin, which is if E. coli is contributing to hyperpermeability. And you're just seeing 1, 2, 3, 4 plus results. I want to talk just a little bit about what that possibly could be, because a 4 plus result on a culture does not equate to a realistic amount of organism. And a lot of the problem is that when they streak a plate to basically look at where the colonies grow, they start with a plate and they put a dab of stool on it. They streak the first section. They fire the wire loop or use a new wooden sterile applicator stick, drag from that first section one time and streak another section of a plate in a zigzag pattern. Change the stick or fire the loop again and do that a third time, and then do it again a fourth time. And the determination of 1, 2, 3, or 4 plus is based on whether or not a colony, a single colony, has grown in those regions, the first, second, third, or fourth region that was streaked on the plate. So imagine if you had a 4 plus result, but there was only 80 colonies on that plate in total. Even if that multiplied up at a high rate, that still would not suggest that there was 10 to the 8 levels of E. coli. And it's also compounded by whether or not the E. coli is growing favorably in the laboratory. So there's times when you might see a no growth on a report. It does not mean that there's no E. coli there. It was the same for Lactobacillus or Bifidobacterium. It just means that the laboratory was not able to meet the nutrient requirements or the environmental requirements of the organism to actually get it to grow. And so that hinders not only results that are 1, 2, 3 plus, but the no growth. So there's no real quantitation involved in a culture-based technology, even if that culture-based technology is using something as sophisticated as a tandem mass or a MALDI-TOF detection system. MALDI-TOF is a great, very sensitive tool for identifying proteins or, in this case, the DNA of an organism, or identifying the organism using both DNA and proteins of the organism. However, it's not set up for running a PCR assay before it and having any throughput. So they're still doing a culture method where they may or may not have even gotten the organism to grow. So ultimately, you do not know how much E. coli is really present. And that really has an effect, because what we see is the effects of E. coli when it's elevated in 10 to the 9th levels. You will then start to see increases in zonulin. And also, as E. coli can produce, or does produce, LPS or lipopolysaccharides, that LPS toxin is pro-inflammatory, and it also leads to overgrowth of other potentially pathogenic bacteria. So the E. coli we know is normal in an overgrowth state has multiple ways it can convey pathogenicity, or the potential for pathogenicity, on the host. We talked about LPS, and we'll also get into the potential for autoimmune autoantibody mimicry. E. coli is known for that. And certainly we're talking about, in this case, zonulin. So we need to be measuring using a DNA-based technology that uses PCR. We need to amplify up the numbers and get a true quantification of the organisms that are in the microbiota to be able to accurately assess whether or not there's an impact from high levels or a deficit from low levels. Another marker that we measure, beta-glucuronidase, is an enzyme produced by cells of the liver, kidney, intestinal epithelium, the endocrine system, and reproductive organs. But it's also produced by organisms within the microbiota. There's a list here, including Bacteroides, Clostridium species, E. coli again, and a few others. And in fact, 97% of the E. coli strains found in the human microbiota do produce beta-glucuronidase. Now, beta-glucuronidase is definitely necessary for the breakdown of carbohydrates, and it's also very necessary in detoxification, specifically, phase 2 glucuronidation pathway. And the measurement, and one of the, basically what the enzyme beta-glucuronidase does is it can deconjugate by breaking the glucuronide bond to the toxins, to the hormones we're detoxing, the metabolites of pharmaceuticals, even vitamin D. And it can break that bond. And so in the bowel, as we were excreting things that are previously detoxed into the bowel, the higher levels of beta-glucuronidase breaks those bonds, and then the either toxin, hormone, or vitamin D compounds like that are reabsorbed. Potentially also the beta-glucuronidase is reabsorbed and increase circulating levels, which then pushes all those toxins back through detoxification. So you can get into the circle of increasing beta-glucuronidase and increasing toxicity, or hormones, and most specifically estrogens. And people go through phases of increased hyperdetox, and also maybe having estrogen-dominant symptoms due to the recirculation of estrogens. And so the cycle continues. We release more back into the bowel, plus what's being produced in the bowel. So being able to measure things like E. coli accurately will give us some idea as to how much they might be contributing to things like beta-glucuronidase, which then might be contributing to circulating levels and causing estrogen-dominant symptoms or increased phase 2 hepatic detox. So in looking at our results, to give you an idea of how to view those, results that are greater than 1,000 but less than 2,500, that number is likely caused by bacterial imbalances. We can't rule out some increases from other sources, because certainly the liver is always producing it because we're always under detox, but probably not too high to where it might be contributing to this large cycle of recirculation, redetoxification, etc. When we get over about 2,500, then certainly there is some increase in production from, likely, can rule out whether it's from bacterial composition. Increased protein is a substrate that the bacteria use to produce beta-glucuronidase, so we need to take those into account. Ingestion of carbohydrates would cause mucosa to do it. And if we can rule those in or out, then we would suggest that in cases over 2,500, there's probably increased production by the liver And the higher the number goes, the more likelihood that it's been more chronic. And of course, then these other symptoms continue, and that you can then look towards to rule in or out the likelihood of beta-glucuronidase contributing to, again, estrogen dominant symptoms and upregulated phase 2 detoxification. So we've seen a report before, but this is an example of a report with from a patient who had a high amount of Bacteroides fragilis. You see in the upper right hand side, 1.0 times 10 to the 10th, and also elevated Escherichia species, which is Escherichia coli. The predominance of that genus is coli, so that's mainly a marker for E. coli. And you can see that's elevated over the reference range. It is 1.0 times 10 to the 9th. So pretty high elevations, 2 orders of magnitude higher than normal. And certainly as we go to page 3, you see that there is quite an elevation in beta-glucuronidase. And again, we would suggest that that's probably a combination of those organs and the microbiota all contributing to this high of a number. And in this particular case, the reason for the test being run was a patient who had estrogen dominant symptoms, and they were in fact looking for an increase of beta-glucuronidase. And it was also compounded by the patient who had some other GI specific symptoms. So it followed suit. So we talked about zonulin and the gut bugs. And the other section that we pointed out earlier a little bit was the grouping of organisms under the opportunistic bacteria that were related to autoantibody mimicry syndrome. So patients with an autoimmune disease that have overgrowths of those particular organisms, which would have been things like Citrobacter frundi, Proteus, Klebsiella, and of course then we have to think about E. coli, as we know that can contribute, and even Yersinia can contribute to the phenomenon of autoantibody mimicry. And so it's very important to look at those as a group, especially in patients who already have diagnosed autoimmune disease. And again, it's good to get a realistic measurement of those to understand how much they may be contributing to their symptoms of their disease. And again, here's some examples of those associations with GI microbes and autoimmune pathology. Well known, the Klebsiella is related to ankylosing spondylitis. You see Citrobacter, Klebsiella, Proteus, and RA. Yersinia with Graves and Hashimoto's, and so on. And as you see here, the last one, E. coli and Proteus, with autoimmune issues in general. There's a term at the top called colonization resistance of this slide. And colonization resistance generally refers to the correct balance of microbes in your microbiota and how well they protect you from overgrowth of other microbes. And again, most of the microbes are present in trace amounts or small amounts on a regular basis, and other things like protozoa are probably ingested fairly routinely. And generally, we have good balance of flora, good production of things like secretory IgA, and those organisms do not take up residency. They kind of pass on through, and we do not turn to dysbiosis or later to disease from overgrowth of those organisms. And again, here's more recent studies suggesting the relation of E. coli and IBD. And these are the types of studies that are being undertaken all over the world, and that information is definitely contributing to how we would interpret a stool report these days. And specifically, again, it does come down to being able to measure organisms accurately by a PCR-based method to know how much of an organism is there, to really understand if something's in a deficit or more specifically in an overgrowth state, as most of the things we talk about are overgrowth. Just their sheer presence does not necessarily mean pathology is coming. It's how much of an organism is present. So it's very important to be able to measure that. And before we get to the questions and answers section, I just wanted to talk a little bit about how you can, if you already have an account set up at Doctor's Choice, you can log into the member login area, or as you see on the bottom, click on the register now. And if you click on, once you go under the GI, click on GI Map DNA Stool test under lab test, then you'll see there's a spot to order test kits and also get other information about the GI Map. And once you get step 4, where you register to order, fill in all the information, place your order as you see here, and test kits will be shipped out within 24 hours, and they ship 2 to 3 day service depending on where you're at in the U.S. You'll also see a price list on the bottom left-hand column here. That kind of brings up the point of what tests are available. So we've been looking at the GI Map, which is the GI Microbial Assay Plus, this comprehensive panel. You can order just page 1, which is the GI pathogens plus the H. pylori, all in one panel. It's called the GI pathogen profile, or if need be, you can order just an H. pylori stool profile. You can order the zonulin on its own, and of course you can add on the zonulin to the GI Map profile for a much reduced price. When you get the requisition forms in the kits, make sure that you sign the form and choose which test is going to be run. So you'd be picking GI Map, GI pathogens, or H. pylori, and whether or not there's an add-on zonulin. And we didn't get into it tonight, but you can actually order antibiotic resistance genes. AR genes are actually on the genome of the organism, and they convey resistance to certain pharmaceutical classes of drugs or drugs themselves, and you could have that information if needed, and that's a no-charge add-on if you are going to prescribe pharmaceuticals. And you can see there's a patient section to be filled out. And of course, Doctor's Choice, if you've worked with them in the past, you know they're easy to deal with and knowledgeable, and will be able to help you with any questions you have regarding ordering, setting up an account, interpretation of reports. Please feel free to contact them. And with that, I want to say thank you for listening to me ramble for a minute, and open it up to any questions that we might have. And while they're getting that opened up, I can probably go through a few questions that people have on a routine basis. A lot of people want to talk about technology. So just to reiterate, it is a PCR DNA-based technology. It's a multiplex assay. Everything we do, all the organisms we measure are all done by PCR DNA. We do no cultures, so we don't do sensitivities that you might be used to. And so I'll comment a little bit further on pharmaceutical sensitivities. Obviously, we can replace that with the antibiotic resistance genes, which are actually a little bit better in that when we look at pharmaceuticals, we can also look at not only on the genome of the organism, but we can look at the entire microbiota. Sometimes using a pharmaceutical based on the phenotypic result of in vitro sensitivity test, I might tell you about the particular target organism, but there could be a gene within the microbiota on a beneficial flora that might, or even a commensal that might be conveyed to the target organism just by introducing the pharmaceutical that appeared to be sensitive on a sensitivity test. So it's really important to know whether or not a gene for resistance is within the microbiota. The other question we get quite a bit is referring to this botanical sensitivities. And I'm sure that if you've been ordering stool tests from Doctor's Choice before, that was the doctor's data stool test, which, by the way, that report format is something I designed in 1999 when I sold my first lab to them. But the botanical sensitivities that are done, again, those are in vitro, and there's really no standardization for botanicals. It does tell you whether or not in the lab there might be some activity of the botanical against the isolated organism. However, in vivo, introducing a single botanical into a very mixed population may not be as very effective. So even in 20 plus years working and being on the phones, when it comes to botanicals, I've always suggested use a multi-formulated botanical product. And the most important thing to do is that introducing a single botanical can be selective like a pharmaceutical and contribute to further dysbiosis. When I say selective, meaning it might hinder the growth of some organisms, kill some organisms, but others may grow even with something as strong as berberine. So a multi-formulated botanical is the best thing to use when trying to do an intervention in such a mixed culture, mixed population as the microbiota. Multi-formulated botanicals are best. So we do not have a live culture. Even if we did, I would not have chose to do botanical sensitivity testing for that reason. And I'm sure that many of you may have questions as you go through. Again, feel free to get in touch with Avexia, Doctor's Choice, as far as ordering goes, interpretations. I'll make myself available. And in the future, we will be pushing through some podcasts to talk about individual sections of our test, other diseases and the relations that they may have for education. And of course, clinical support is always available to go over results. Okay. Run a panel. I think we're having a little technical difficulty. Don't have any questions coming through at the moment, and don't hear Frank, but certainly it's been a pleasure. We are very excited about the opportunity to partner with Doctor's Choice and Avexia and offer the DNA technology of the GI map profile. And I'm sure we will be putting together another webinar very soon, and we'll have some clinicians present that can go through case studies and get some in-depth education on pattern analysis that we see in diseases. That's probably going to be new. And of course, anytime you're looking at an assay like this, just understanding the results can be a challenge, and we certainly would want to make sure that everybody understands the results they get, and we'll be happy to do so. So with that, if we don't have any additional questions I can cover, I want to say thank you once again, and we look forward to working with everybody. Have a great evening.